Quadratic function y is equal to x squared minus 4ax plus b passes through 3, 5 and its vertex is on y is equal to 2x. Solve for a plus b. So what is vertex before solving for this question? And they mention about the vertex here, and the vertex is a thing that can be defined by the leading coefficient. And usually we know the leading coefficient as a, and there are going to be two cases that define the vertex. When the a value, which is leading coefficient, is greater than 0, which means when the a value is positive value, the graph of the quadratic function will go upward. So the graph of the quadratic function will go upward. And if the quadratic function is going upward, it will look something like this, for example, which means while it keeps going up, it will only contain a point, which we also call it as minimum point, or we can also call it as lowest point. And there's the second case, when the a value is less than 0, which means when the a value is negative. When the a value is negative, the quadratic function's graph will go upward, will go downward. And when the graph goes downward, for example, it will look something like this. And for that function where the a value is less than 0, it will contain a point which will going to be the maximum point of that quadratic function. And for the vertex, the concept of the vertex came from here. And when we kind of think about the number of possibilities of minimum point and the maximum point, if you think about both of them by adding two cases, minimum point and then maximum point, that we're gonna the result will going to be we can call it as a vertex of the function. So the vertex of the function contains two things, which can be minimum or maximum point, but those numbers possibilities are depend on the value of the a, which will going to be the leading coefficient of the quadratic function. That they're talking about minimum maximum point, but they're talking about the vertex. And for the vertex of this function, in order to find the vertex, we need to convert this into a vertex form, because vertex form is a form that is optimized when it comes to solving for the vertex. So before you solve for this, vertex form is exactly the same thing with solving for the perfect square. We're converting it into a perfect square. So if you write our function down, which will going to be y is equal to x squared minus 4ax plus b. The only terms that we are caring about when it comes to solving for a vertex form is the x terms, which means we can put parentheses not to be confused with other terms. And then there will going to be a constant, new constant as a step of the quadratic function's vertex form. And according to its property, it will going to be the half of the first power variable term is squared. For divide this one divided by 2, we're going to be negative 2a squared. We're going to be 4a squared. So we're going to be plus 4a squared. But since we added 4a squared, we also need to subtract 4a squared in the outside of the parentheses, because if we just have 4a squared, we are adding 4a squared from our quadratic function, and that will affect our original quadratic function. But the reason why we didn't count as x value into our step of making constant is because for this term it will going to be obviously going to be a constant value. But constant means it is a term without any variables. which means it never varies. But if it contains an x value which is variable, this value will going to change or vary depends on the x value. Well, we subtracted for a square again, but we still have our constant as b, so we can write s plus b. So if you write our quadratic functions, our new quadratic functions down again, it will going to be x squared minus 4ax, then plus 4a squared. But if you think about this, and we still have negative 4 squared plus b, but for me, I'll just change the order. But we can still simplify, or we can just make this simple term x squared minus 4ax plus 4a squared into a perfect square. So if you make this into a perfect square, it will going to be x minus 2a squared. But we remember that if we just extend our perfect square again, we're going to get exact same function. And we still have our constant, which will going to be positive b, and then minus 4a squared. And this is our new vertex form. And from here, we'll be able to solve for the vertex. And the vertex will going to be 2a, comma, b minus 4a squared. And we can see that for the 2a, it is a x value if we convert, and for b minus 4 squared, it will going to be the y value of our vertex. But we can know one thing from here is that our original function's leading coefficient is 1, which means it is a positive value, and when the a value is positive value, the graph will go upward and it will only contain a minimum point. So we can say that this vertex will going to be a minimum value or the lowest point of a quadratic function. Y is equal to x squared minus 4ax plus b. So there is a two equation with same kind of variable, which will going to be a plus b, and the a plus b are things that we're trying to find. So we can use the simultaneous equations, which we should make one side same, and then input the another values, another equation to solve for the another term. But another term or another side should be same in order to convert into our elimination equations. And for b minus 4a squared is equal to 2 times 2a, which is basically equal to 4a. Firstly, for a term b minus 4a squared is equal to 4a, we can just put our 4a to the other side in order to isolate every single terms into the left side, which will going to be negative 4a squared plus 4a plus b, so it should be minus 4a plus b should be equal to 0. And the reason why we did into 0 is because it's our y value, which is output, is because it's easy to calculate. And for the second one, since we made one side into 0, we also need to make another side equal to 0. So this side should be equal to 0. And then for the 3 minus 2a squared plus b minus 4a squared is equal to 5, all you have to do is we can just isolate and then subtract 5 to the both sides. So it will going to be negative 4a squared, and then plus 3 minus 2a squared, and we're running out of spaces. So negative 4a squared plus 3 minus 2a squared, and then we have our plus b, and then minus 5. And that is still going to be equal to 0. And this is why we can use elimination equation. Since the two sides are equal, they're all equal to 0, which means these terms and then this term should be equal because they both are equal to 0. So we can use our elimination equation by putting equations such as negative 4 squared minus 4a plus b, which is our first term, that is equal to the second term, which is negative 4a squared plus 3 minus 2a squared plus b minus 5. The reason why we could make this kind of equation is because one of the sides are equal. One thing that for this, so 2a comma b minus 4a squared. This is our vertex of this function, but according to what the question said, this is relying on the y is equal to 2x graph. But the y is equal to 2x graph, if we graph it, it will going to be a straight line that satisfies equation y is equal to 2x. So if you write our equation down, y is equal to 2x, that means if we input our values to our function y is equal to 2x, it will going to satisfy. So for the 2a, we can input it to our x value, and then for b minus 4a squared, we can input it into our y value. So it will going to be like this. At first, it will going to be b minus 4a squared is same thing with, so 2 times 2a. But if you use the distributive property of the variable 2, in order to cancel out this parenthesis, it will going to give us 4a. This will going to be our first equation that we made. And for the second equation, we can make it through our question that it says it passes through 3, 5. So for our function, x minus 2 squared plus b minus 4 squared, we can write it down. X minus 2a squared plus b minus 4a squared. And then from here, we can input 3, 5 into our equation. Again, we are inputting the value of x value as 3, the value of y value as 5. So if you convert this, it will going to look like 2 minus 2a, should be 3, minus 2a squared plus b minus 4a squared is equal to y, which will going to be 5. And this is our second equation that we converted. And we used it through our given coordinate, which was 3, 5. So there is a 2 equation with same kind of variable, which will going to be a plus b, and the a plus b are things that we are trying to find. So we can use the simultaneous equations, which we should make one side same, and then input the another values, another equation to solve for the another term. But another term or another side should be same in order to convert into our elimination equations. And for b minus 4a squared is equal to 2 times 2a, which is basically equal to 4a. Firstly, for a term b minus 4a squared is equal to 4a, we can just put our 4a to the another side in order to isolate every single term into the left side, which will going to be negative 4a squared plus 4a plus b, so it should be minus 4a, plus b should be equal to 0. And the reason why we did into 0 is because it's our y value, which is output, is because it's easy to calculate. And for the second one, Since we made one side into 0, we also need to make another side equal to 0. So this side should be equal to 0. And then for the 3 minus 2a squared plus b minus 4a squared is equal to 5, all you have to do is we can just isolate and then subtract 5 to the both sides. So it will going to be negative 4a squared and then plus 3 minus 2a squared. And we're running out of spaces. So negative 4a squared plus 3 minus 2a squared. And then we have our plus b and then minus 5. And that is still going to be equal to 0. And this is why we can use elimination equation. Since the two sides are equal, they're all equal to 0, which means these terms and then this term should be equal because they both are equal to 0. So we can use our elimination equation by putting equations such as negative 4 squared minus 4a plus b, which is our first term, that is equal to the second term, which is negative 4a squared plus 3 minus 2a squared plus b minus 5. The reason why we could make this kind of equation is because one of the sides are equal. So in order to simplify this equation, we can have 4a squared to the both sides, which we're going to cancel out. Then we have negative 4a plus b, then plus 3 minus 2a squared plus b minus 5. We can extend our formula, which is 3 minus 2a squared. At first, we can write our new function down, which will going to be negative 4a plus b is equal to 3 minus 2a squared. If you extend it, it is the same thing with 3 minus 2a times 3 minus 2a, which will going to be 9 minus 6a minus 6a plus 4a squared. So it will going to be 4a squared minus 12a plus 9. But we still have our negative 5. And it's easy to simplify right now that 9 minus 5 will just going to cancel out as positive 4. And then we can add, and we need to write our b terms down. And from here, we can subtract b to the both sides, which will be going to cancel out. And we can also add 4a to the both sides. We're trying to isolate the every single terms into the right side. And then we're going to get, finally, the left side. They all cancel out. We only end up with 0. That is equal to 4a squared minus 8a and then plus 4. So we can convert this into a binomial form, which we can end it up solving for the a value. But before I do that, the leading coefficient, which in this case will going to be 4, if it is not equal to 1, it's hard to solve for it. So all you have to do is we can divide 4 to the both sides, since we knew that every single terms are divisible by 4. We're going to get a squared, then minus 2a plus 1, and that should be equal to 0. And from here, we can convert this into a binomial. And according to its property, there will obviously going to be two nomials, because bi means there is 2. Then a times a makes a squared. And for the unknown quantity that I'm pointing out, unknown quantity, and that is equal to 0. If you multiply these two numbers, we're going to get positive 1. If you add it, we're going to get negative 2. So we can think about this through our 1 factor of the 1, which we're going to be 1 times 1, negative 1 times negative 1. If you add 1 and 1, we're just going to get 2. If you add negative 1 and a negative 1, we're going to get negative 2. So we can write a minus 1 and a minus 1. But this is exactly same thing with a minus 1 squared, but since we knew that they're multiplying exact same thing from here. So we are trying to find the value of the a, which makes this equal to 0. So a minus 1 is equal to 0. We can add 1 to the both sides, and then we're going to have a is equal to positive 1. We found the value of the a, which means we need to find the value of the b. And for the value of the b, if we input our a value into one of the equations from here, we'll be able to solve for it. Here's the easy one, easy equation. And our easiest equation we're going to be b minus 4a squared is equal to 4a. So b minus 4a squared is equal to 4a. And if we input our value, which a is equal to 1, we're going to get ended up by b minus 4 is equal to 4. And all you have to do is we can add 4 to the both side in order to isolate the b term. And then we're going to get b is equal to positive 8. We're not trying to find the value of just b. We're trying to find the addition of the a and a b. So a plus b, which we're going to be a is 1, b is 8, and our final answer we're going to be 9.